For this next problem, I think, in all honesty, that I forgot to put a parenthesis, or I shouldn't have had the 3 there. Something weird happened. Rather than saying let's not worry about it, let's actually look at the problem and see if maybe we can learn some ideas from it. Just like in the previous example, I need to find the zeros and I need to find the restrictions. And so for this problem, let's start with our restriction. Let's look at the bottom. Hopefully you can look at the denominator and figure out how that factors. What two numbers multiply to give us 10, yet add together to give us -7? Hopefully your response is x minus 2 and x minus 5. Now, in terms of restrictions, that's telling us that when I find a 0 here, I don't want x to be 2 and I don't want x to be 5. Those would be restricted values. Those are going to create asymptotes. In the top, I know how to break down a difference of cubes. You learned that in Algebra 2. You probably forgot about it. But this is not a difference of cubes because I don't have anything times itself that's going to produce 3. I mean, I can break it down into radicals and cubed roots and all that stuff, but I didn't want to go that direction. And so what I'm going to do is, once again, try to show you some of the power that your calculator has. And so I'm going to start by hitting my Apps button. Let me clear my home screen. I'm going to hit my Apps button right here. Apps button, APPS for applications. I hit my Apps button and I have something called a Polysmlt 2. That's a polynomial root finder and simultaneous equation solver version 2. So I go down to that. It opens up this window here. I'm looking for a root finder. Root finder means when I set this equal to 0, can you tell me where that's going to happen? So I hit polynomial root finder. It is to the 3rd power, so it's already highlighted there. And I hit next. And then it's asking me for the coefficients here. When I look at this, my cubed coefficient, that would be the A3 here, is 3. I don't have a squared term, nor do I have a regular x term. So the next two would be 0, 0, and then a to the 0 would be my constant. And I'm going to write -27. As I type that in, use your negative button here, not the minus button. So I go -27, and then I'm going to tell it to solve. It's thinking. And now it's solved, and it gave me a value of 2.0801. I'm rounding to get that. And so what I'm finding is from this top value I have 3x cubed minus 27. I'm not going to mess with that. But it is telling me that I would have x equaling 2.08. It would be 001 or 01. So I'm just going to call it 2.80. I'll go 3 decimal places. And then, like the previous examples, what I want to do is go to my number line and I want to plot all these values to see what's going on. Something really strange is going to happen here. As I locate my 2, right there's 2, that's a DNE, it's an asymptote, and 5 is an asymptote, so DNE. What's strange is right next to this asymptote, which is pretty close to it there, 2.080, I'm going to have a 0. So at 2. We'll write it on the side here, 080, I get a 0. I need to check all the values in between here and see what's going to happen. So for this one, again, I'm going to cheat here a little bit. I already have this plugged in my calculator. And so I'll show you where it's at. I've got the y equal, I already typed it in. And so I'm going to go to my variables. I'm going to pretend like I can't graph this. Call up that function. And I just want to plug some values in here. I want to see what's happening beneath 2. So let me throw in something like -5. -5. I'm getting a -5.74. So over here, this is going to be negative, meaning it's beneath the x-axis. I need to find a number between 2 and 2.080. That's not the easiest thing in the world to do. So when I go to my home screen, I'm going to put in something like 2.0001. I'm sure that's going to fall between those two values then. And when I do that, it gives me 9,988. That's pretty positive. So right inside here, this is positive, meaning it's above the x-axis. It goes to 0. Now I want to try a number between this 2.08 and 5, so we can try something like 4. And when I try 4, I get a negative 82. Again, I'm not concerned about the value, but whether it's positive or negative. So this is negative. And then I want to try a positive or value above positive 5. So let me try something like 11. That gives me a positive result. So now I have a sign check. I have an idea what this graph is going to look like. I want to look at what my zeros were again. I just like to list this out. I have x equaling 2.080. That's a 0. I have asymptotes at, and we're talking vertical here, vertical asymptote at x equaling 2 and x equaling 5. So I don't really want to have those. I can't go to those values, so we say not equal. And then if I were to look at the ratio of leading terms here, the ratio of leading terms would be 3x over x, which implies that I would have a slant asymptote. To find the actual slant asymptote, I'll ask that in a later question, you would divide this out to find the real slant asymptote. It's good enough for my graph here to understand that it's going to go roughly around, and so we're going to say slant asymptote, roughly around y equals 3x, because the ratio of leading terms would be 3x to 1. Now, there could be another value on this. Right now, I'm just going to go with that ratio of leading terms and say y equals 3x, so I know I have a slant asymptote. Now, as I try to graph this, I'm going to have 2.085. 2 is a DNE, so it's an asymptote. 5 is a DNE. And then I'm just going to follow what this paper is telling me to do. It tells me I'm beneath the x-axis. If I'm beneath the x-axis, my guess is that this thing is going to have to follow that slant asymptote of y equal 3x. So it's going to shoot up something like this and stay down towards your asymptote, your other asymptote. And so if I have this y equal 3x, it's shooting up something like that. I'm going to have some kind of graph that looks like this. It has to follow that slant asymptote, and then this vertical asymptote is going to draw that back down like a black hole. It says you're coming back down this way. Okay? And then the next part tells me that I'm positive. Well, if I'm positive, it has to follow this asymptote. So it's going to draw it all the way up there. It's going to come to that 0. And then it's going to have to flow down this way and go to that asymptote. Okay, so come down, follow it over there. And then over here at 5, it's again going to have to follow that slant asymptote. And so it probably exists up here somewhere. You know, it's got to follow this asymptote here. So it's going to come down, and then it's got to go up and follow that y equal 3x. All right? Now let me graph this. I'll go my y equals. It's already typed in. I'm going to hit graph, and we'll see what happens here. Good. And then what's happening is this little piece is not showing up here. If I zoom out enough, I'm sure I'll see that. I really don't need to go through all of it because what I'm looking for, again, the question said, what is the domain and the range? So as I pull this all together, we talk about the domain, the collection of x values. I can hit just about every x value as I run across the x-axis. I can hit every x value. The only place where I have issues is at 2 and 5. So I can say we want to go from negative infinity up to 2, I can't have 2, unioned with 2 to 5, I can't have 2 or 5, union with 5 to positive infinity. So here's one where we had the interval notation where there's 3 distinct sections. There's this section, there's this section, there's this section, and I allowed for me not to be able to have 2 and not to have 5. So that's why we used our parentheses there. Then as we talk about our range, once again, you're just looking on the y-axis. My y-axis would be over here somewhere. You can come down. As I run this pen up, can I touch a y value somewhere? And so the whole way up, I'm hitting this y value right here. This is going to give me a y value the whole way through. I don't need to know what this max or this min is, because in this center piece, I hit every y value you could ever think of. And so I would say my range would go from negative infinity all the way up to positive infinity. Now, an interesting concept would be if I didn't have this middle piece, then my range would go from negative infinity up to this point, disappear for a while, and then it would start all over again. It would start at this point and run up. How I would find these if I needed to. I don't need it because this middle section covers all the y values. But if I needed to, I'll just go back. It's from the last problem. It's the same idea. I'm going to hit second trace, and I would look for a max to find that piece there. I would have to do a left bound and then go to the right of where my suspected max was, hit enter, and then a guess. And it will report a guess. I think what happened is I hit the enter twice there. Let me try that again. So here's a left bound. Here's a right bound. My guess is somewhere in there. And it's telling me at negative 1.61 for my y value. And then I could do the same over here where I find a minimum and it'll report that. For this problem, for the second or third time, I didn't need to do that because I have every y value accounted for right here. And that's why I told you that the range went from negative infinity to positive infinity.